What do you think? How did I do? I had to do my own buzz today. Can't go to the barber. It's like not a good place to go with coronavirus land. Okay, so, sometimes I might not be looking my best. I might have a bad hair day. You need to forgive me, and I'll forgive you too. Okay, we're going to go over the math Olympiads. The POW, baby. Here it is. POW. Let me get the book. Then I'm back. Okay. So we got set 3, Olympiad 3. Let's do the first one, which is 3A. You should have put your answers already into the form. Okay. And then you watch this to see if you got it right. Lauren is the youngest of 4. The average of their ages, and they're all different numbers, whole numbers, is 9. The average is 9. So there are 4 kids. To figure out the average of something, you add them up, you divide by the number of numbers, and then you get 9. So something, there were 4 kids. So we did something divided by 4 equals 9. What could go there? Well, if it's something divided by 4, it's 9 times 4 gives you the something. Yes. When you add the kids' ages up, you get 36. So then, they've got to average 9. Okay, you start thinking of 4 consecutive numbers. Right? Are they consecutive? They don't have to be consecutive, meaning one right after the other, but they're probably going to be. We'll see. So, we know that Lauren can't be 9. If she's 9, they'd have to be 9, 10, 11, and 12. Well, the average of that's not going to be 9. So you got to think of 4 numbers. She's got to be younger than 9. Let's see. Let's try her at 8. So if she was 8, next sibling's 9. The youngest the other 2 guys could be is this. Let's add those up and see if we get 36. When we can add them up to 36, we have the right answer. 8, 9 is 17. Let's do this. 10 and 9, 11 and 9 is 20. 38. 38. Is 38 36? No, it really isn't. Okay, so let's move on. Let's make, what's her name? Lauren. Let's make her 7. Let's try 7. So 7, 8, 9, 10. Ooh. Now, with 4, the average, there's no middle number. So I was starting to think if there was one in the middle, that would be the average, but there's not. I can already tell with 4 numbers, if they're consecutive, the balancing point is going to be right in the middle of the middle 2. So, and you think, really, are you sure, Bri? Watch me. The average will be 8.5. Okay, let's remember I said that. Okay, so we got 7 and 8 is 15, plus 10 is 25. 25 plus 9 is 34. 34 divided by 4, well, 34 and a half is 17. Half of 17 is 8.5. Right in the middle. Teacher. But I'm thinking, wait a minute. This could be the bomb. Because what did we get for the 8, 8, 9, 10, 11? Was too big. This is not too big. It's too little by 2. We could just make somebody a little bit older. All right, what's the oldest that Lauren can be? The question is, what is the oldest that Lauren can be? It's going to be 7. We already figured out. Because look, 7, you're thinking, really? I don't get it yet, Bri. Look, I want to get this total to be 36 instead of 34. Fine. Make this last turkey 12. 8 and 12 is 20. 9 and 7 is 16. Put them together, you get 36. That works. But let's say I didn't want to make that person 12. I go back to this. I could have made this person go up by 1 and made them 10, and make this one go up by 1 too, make that 11. It'll still be 36. That's why I didn't ask you this exact age of the kids. It just said, what's the oldest that she could be? It's going to be 7. And the reason is because we know is 8's too big. If you do 8, 9, 10, 11, you get 38. 38 is too big. When you drop down to 7, there's a couple different answers you can get. So the oldest that Lauren can be is 7. That's number 1. And now we're going to do number 2. Which is not number 2, it is actually number B. Let us put here like this. Okay, very good. All right, to the 6-digit number. 1, 2, 3, 4, 5, 6. We got 6, 3, 9, 0, 4. You got to know some tricks to do this one. That's why it's only 15%. Is an even multiple of 27. So if you count by 27s, you're going to hit that. So that is not the quick way to do this, is to count by 27s until you get 630-something thousand 904. Don't do it like that. Okay, so what digit does X represent? So the whole thing of this comes down to 2 tricks. 7 is divisible by, as soon as you say 27, if you really know your math facts, what comes to your head? Yes! 9 and 3. 9 times 3 is 27. Bing! You knew that. Now, there's a trick for knowing if 3 fits into something, and there's a trick for knowing if 9 fits into something. And both of them, here's the trick. If you add up all the digits, and you get an answer, if 3 fits into that answer, 3 fits into the number. Right? The same trick is true for 9. If you add them all up and you say, hey, does 9 fit into that number? Then 9 fits into the big number. You're like, I don't get it. Okay, let's do 441. So you say to yourself, does 3 fit into this? 4 plus 4 is 8, plus 1 is 9. Does 3 fit into 9? Yes, it does. So 3 will fit into 441. You're like, dude, are you serious? I'm supposed to just like believe you? I'm like, yeah, you really should believe me because I'm like a teacher and I've like had some training, or at least I tricked enough people to think that I'd had that training, which is pretty much the same thing. Because if I'm smart enough to trick people to think that I actually went to college, then, you know, maybe I actually did, okay? Or I don't even need it, so 147 times. So, yeah. And I also told you that if you add them all up and 9 goes into the number, it would also work. So does 9 fit into 441? Yeah, you're going to watch, so let's see, 40, 50, 40, 360, 49 times. Sure does. Okay, so, but now here's the cool thing. We don't care about the 3. Because everything that a 9 could fit into, a 3 could fit into. Because all 3s fit into all 9s. So count by 9s. Does 3 fit into 9? Sure. Next one is 18. Does 3 fit into 18? Yeah. Next one's 27. Does 3 fit into that? Yeah. That's the whole thing we've been talking about. About 36. Yeah. It's always going to work. So all we care about is the 9. So we add these guys up. 6 plus 3 is 9. 9 and 9 is 18. 18 and 4 is 22. So 22 plus some number we don't know has got to get to a total that 9 fits into. Well, guess what? There's only one that's anywhere close, which is 27. That's that magic number again. Okay, 27. And the reason this is going to work is because 9 times 3 is 27. So if this works for 9s and it works for 3s, it's going to work. I believe in this. Okay, so X has got to be 0 through 9. And we've got to add these, all these digits add up, I've got to get something that 9 fits into. So if I had a 0, it'd be 22. This is, so the 0, so here we go, I'm going to make a table. I'm going to say X and total. Total. When X is 0, the total is 22. When X is 1, it will go up to 23. When X is 2, it'd be 24. None of these 9 fits into. When X is 3, it'd be 25. When X is 4, it'd be 26. When X is 5, it's 27. Hey, 9 fits into that. That means 5's going to work. Let's keep going, see if there's another one. 6, it'd be 28. 7 is 29, and 8 is 30, and 9 is 31. 9 doesn't fit into any of these things. So, the one that works is a 5. X has got to be a 5. And just to be sure, am I going to do that for you? No, you're just going to have to take my word for it. Okay? It's 5. It's the only one that works, and it's because of the 9s and 3s. Yeah, okay, let's go on to the next one. All right, Next one. That one's pretty hard, I'll tell you what. This one, I like this one because it sounds impossible, but it isn't really impossible. So when she puts in a 1-digit number, it doubles. She puts in a 2, you do the sum of the 2. So you're going to do what she puts in, and this is what it spits out. And I'll get 2 tables going here. In, out. And I'm going to do it 50 times right here. Psych! I'm not going to do it 50 times. You're going to get started, and you're going to see a pattern, then you don't have to do it 50 times. When I saw 50, I just wanted to just kind of feel a little bit sick in your stomach or a little bit violent. You wanted to hurt something. Chill. You're going to have to do it 10 times. All right. When she puts in her 1, they tell you to start with a 1. She puts in a 1, it doubles it. So it spits out a 2. She then takes her 2, sticks it in the machine. So she puts in a 2, and it spits out a double that. She puts in her 4 now, and it spits out an 8. She sticks in the 8, and it spits out 16. It doubles it, and now is when everything changes. She puts in the 16, and this time it adds the 2 digits. So it spits out a 7, because 1 plus 6 is 7. You're like, okay, now I get the idea. So I put in a 7, and I double it, so I get 14. She puts in the 14, add them, she gets a 5. She puts in a 5, and she gets a double, she gets to a 10. And now she puts in a 10, and it spits out a 1 again. She started with a 1. Now she's back with a 1. What do you think's going to happen when she sticks this 1 back in? I bet it's going to get out to 2, don't you? Uh-huh. So it's just going to keep doing the same. Well, how many have I done? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 10th one is where it would be back to here. That would be the 10th. So it's 9 to here, and then 10 goes back to there, which means 20 goes back to there, 30 goes back to there, 40 goes back to there, 50 would be right there. What is the 50th number to be inserted? 50 is just putting in a 1 again. See what I mean? You're like, oh, dude, that wasn't as hard as I thought. Oh, that was C, by the way. Now we're up to 3D. Oh dear, I've lost my eraser. Name 3 consecutive numbers. There's that word again. It sounds so cool, doesn't it? Each less than 100, such that the smallest is divisible by 6. The smallest is 6. The middle dude is divisible by 5, and the largest is divisible by 4. So, you got to know some tricks. If you're wondering, how do I know if 6 fits into something? It's got to be even, and the 3 trick has to work. The one I told you from last time about adding up the digits. So the middle one, how do you know if 5 fits into some bigger number? That one's the easy one. It either ends in a 0 or it ends in a 5. That's the easiest one. How do I know if 4 fits into a number? For the numbers under 100, there's no trick. There is a trick if you're bigger than 100. So let's say like 36,748. To know if 4 fits into that, all you do is the last 2 digits. Does 4 fit into the last 2 digits? Does 4 fit into 48? Yes, it does, because it's 12 times 4. So 4 fits into that whole sucker, no matter what I put over here. I could put an 8 here. I could put a 3 here. I could put a 9 here. Doesn't matter. 4 is always going to fit. So we don't care about the 4 right now, because that trick doesn't work because it's a 2-digit number, because it's less than 100. So what I would do if I was you, and I think I am you right now, aren't I? Because I'm solving these, is I'm going to start with the 5s. I know they're consecutive numbers, and I think it's going to be pretty big. 3 consecutive numbers. And I just got to come up with these rules. So let's go to 5, the number 5. If that was the middle number, the middle one is divisible by 5, so it would have to be 4, 5, and 6. Is the smallest one divisible by 6? Is 4 divisible by 6? Nope. So we're done with that. So now I leap up to 10. 9, 10, 11. Is 9 divisible by 6? Nope. So now we go up to 15, which makes 14, and I can stop there because I know that 6 doesn't fit into 14. So then I go up to 20, and now we're cruising. Here we're cooking with gas. Wait, 6 doesn't fit into that. So we go to 25, 24, 6 fits into that. I'm getting excited. 26. What is the last thing? 4. Does 4 fit into 26? Oh my. No, it doesn't. So it's not this. So we're up to 30. 30. 29. That doesn't work for 6. 35. 34. 6 times 6 is 34, right? No, it isn't. No, it isn't. We're done with that. 40. 39. Does 6 times something be 39? Don't be saying yes to that question. 45 means 44. 6 times something, 44? No. Boy, how can he do this so fast? Maybe because he memorized his math facts, kids, while you're sitting at home trying not to catch a virus. Work on them. All right. 49. Does 49? No. 55? Ooh. Oh. 9 times 6 is 54, kids. 55 is divisible by 5. The next number is 56. Shivering with excitement. Does 4 fit into 56? Breathe. I know that 12 times 4 is 48. How many are left to go from 48 to 46 to 56? 8. Can I get to 8 by counting by 4s? Yes. 14 times 4 is 56. So this combination is the answer. Right on. Right on, right on. All right, last one. Okay. This one is one of those things, if you're spatially good, you were probably able to do it. And if you're a little spatially challenged, you probably didn't do that well with this problem. I have to look at teacher creating 5s. That's not easy to do, people. Our bodies don't like to make numbers. All right, I'm just going to show the 5 by 5 in the front. So we got a 5 by 5 by 5. We got to hack off all the ones that have any paint on them. So I want you to imagine, so this is going back like this, and these are going, let's say, just draw this layer here. All right, I'll just draw it. Fine. Oh gosh, this is hard. Yeah, I thought about art school. Well, thanks for asking. Okay, so now I got 5 by 5 by 5. But I want you to focus right here. Imagine that I'm going to slice off this whole face, right? Because all of these guys have paint on them. So I just took away that whole face, which means instead of a 5 by 5, look at this top guy. He's only 4 this way. But wait a minute, I've got to slice off the back face too, because those are all going to have paint on them. And then I've got to slice off this whole left side. And I've got to slice off the stuff that was on the whole right side. All right, and if I can imagine this was, I would slice off the top too, but it'd be one layer down. Basically, you end up with a 3 by 3 by 3. I don't feel like I explained that very well. Yeah, me neither, Brian. Yeah, but you're taking off one from the left side, one from the right side, one from the top, one from the bottom. You do that all the way around, you're going to have a 3 by 3 by 3 left. And that's the trick. And then you're like, wait, but that's not what the question says. Oh, but wait, there's more. You got to do 3 by 3 by 3 is how many cubes? How many total cubes is there? 3 times 3 is 9. Times 3 is 27. There are 27 cubes left in the middle. They told you in the problem that they started out with 125 small cubes. And the question is, how many of them are not painted on any face? They could have asked harder questions like, how many are painted with one face? Blah, blah, blah. Like, that would have been annoying. So if I know that 125 is the total, and 27 of them don't have any paint, I do 125 minus 27, don't I? And I get 98. Bam. Wait, is that what it says? How many of them, small ones, are not painted orange? Oh, that's just the 27. So I am done at 27. 98 did have some kind of paint on them. And 27 didn't. So these are the painted ones, and these are the happy, unblemished ones. And kids, that's the end of that pal. That was challenging, I know, but it was good for you.